Electronic circuits converts power to battery voltage, solution to create new power sources from the grid. Type 1. Using a step-down transformer, low voltage. This electronic circuit converts 220 volts AC to various lower voltage levels, 3 volts, 6 volts, 12 volts, 24 volts, 36 volts, 48 volts, 68 volts, 98 volts, 110 volts, and 120 volts. However, these lower voltage signals remain AC. To convert these low voltage AC signals to DC, we use a bridge rectifier consisting of 4 diodes. This rectifier creates an output signal separated into negative and positive voltages along 2 branches. These voltage branches are then charged to a capacitor, which discharges a signal that approximates a DC source with a relatively constant voltage over time. While this signal isn't as flat as classic battery DC, its effective value is comparable to that of a battery DC source. If a DC power supply with an invariant effective value is needed, this circuit can be used. Type 2. Using a resistor as a potentiometer for 220 volts power. The potentiometer circuit uses a resistor to determine the voltage but consumes minimal power at the resistor. This circuit divides the current from the 220 volt source into 2 branches. One branch goes into the capacitor, and the other into the resistor. We take the voltage and current from the resistor branch to convert again. Here, the current passes through a bridge rectifier diode, consisting of 4 diodes, and is potentiated to create an arbitrary voltage based on the value of the potentiometer resistor. The resistor and capacitor will divide the voltage in the potentiometer circuit at the output. The output voltage value will be 3 volts, 6 volts, 12 volts, 24 volts, 36 volts, 48 volts, 68 volts, 98 volts, 110 volts, 120 volts, etc., depending on the potentiometer resistance value. Type 3. Using a resistor as a potentiometer with an additional Zener diode. This circuit is similar to the one using resistors and capacitors as a potentiometer from a 220 volt source, but the output includes an additional reference to a Zener diode. Adding this diode stabilizes the output DC power source, ensuring a constant output voltage even if the input signal varies from 220 volts. Zener diodes are used to create rails that provide stable low power from higher voltages and provide reference voltages to circuits, particularly stabilized power supplies. They are also used to protect circuits from overvoltage, especially electrostatic discharge.
And finally, we have a gift for you that is tricks to reduce your electricity bill by at least 75%. And the way to complete energy independence, get rid of the monopoly of big energy. You will never have to pay for electricity. Method: amplify electricity to make output power greater than input power. See link in description. Thanks for watching.